All right, moving along. We have our fourth speaker of the morning, another Cal Bear alumni. Joel Levine is going to be speaking about maintaining NIH funding and managing your funds. Currently, he's a professor and vice chairman of research of pediatrics at Columbia University in New York City. He's also chief of gastroenterology, hepatology, and nutrition at Columbia University and Morgan Stanley Children's Hospital. He serves on the executive committee and as a co-chair of the steering committee for the NIDDK-sponsored non-alcoholic steatohepatitis clinical research network for the past 12 years and has served as the chair of the NIH Committee for Grant Review, external advisory boards, data and safety monitoring boards, and NIH workshops. Please join me in welcoming Joel Levine.
Thank you for that nice introduction, Ben. I also want to say that Sohail's presentation was an excellent example of a good recipe for maintaining NIH funding and how it's done. I show this winter scene because even though it's autumn, it seems bleak, and especially for after that first R01 in terms of maintaining NIH funding, but you can see that there is potentially a sunrise through the haze there, or perhaps it's a sunset, I don't know. And here's my disclosures for my being a consultant for some companies. Most of these relate to mock FDAs or protocol development for products that they have in the works. Here's my first slide about why you may not hear about your grant. One time when I went for a meeting at NIDDK, I decided to drop in and see what the real working conditions are for project officers and review officers at NIDDK. And it's a bad picture that I took on my iPhone, I guess, but that's Dr. Ed Dew, who's at NIDDK, and it looks like he has a lot of work to do. So this is why sometimes it may take a little bit for him to get back to you. So in this overview about maintaining NIH funding and managing your grants, some of these things are a little bit duplicative of what Dr. Putskalny and Dr. Sain has already said, and I'll try to skip over those things quickly in terms of the state of funding, the number of applicants and pay lines, types of NIH grants, and making sure that you review the requests for applications and the weekly notices, getting ahead of the grant so you get a good head start, the times that it takes to get renewed and have multiple grants, some bit of advice about managing an administration, and some discussion of carryovers, no-cost extensions, and what to do to weather the storm at times that you aren't able to maintain your NIH funds. I went through and found through NIH Reporter and Blue Ridge Institute makes a compilation of the the order of funded researchers in pediatrics, and there's a lot of pediatric GI hepatologists that are at the very top of the game. Ron Sokol is obviously a past president of NASPGHAN and the AASLD. He's the #1 funded pediatric researcher in the United States, and most of that is by virtue of his being the PI for the Clinical and Translational Science Award that he heads at the University of Colorado. University of Colorado is also the most funded pediatric department in the United States, in part because of his being the principal investigator for that. And Jim Hybe, who's also a principal investigator of a CTSA at the University of Cincinnati, is #13. Rob Squires is right after that, and that's primarily due to pediatric acute liver failure network that he heads through 2016. David Perlmutter through some development awards, as well as his own research in alpha-1 antitrypsin deficiency. I was also fortunate to have through the NASPGHAN a fair amount of funding. And what's interesting to me is that everybody that's at the top there, though, is still hepatologists, so we rule. And so maybe you should go into liver disease research. Here's something that's taken from NIH website, and here's looking at appropriation in current and constant dollars, you could see from the period of around 1996 to 2003, it was great times for the NIH in terms of congressional appropriations, going from $11 billion to $27 billion. And then in terms of correcting for inflation, it's still almost a doubling of the NIH budget during that time. Then it went into a period where it was a slow climb in terms of the amount of money, but in terms of actual dollars corrected for inflation, it was actually a decrement, except for the years when there was the American Recovery Act era funding that came in to give a lot of funds in 2009 and 2010. It was another good time. But since then, and particularly in the last couple of years, the budget went from almost $31 billion down in 2013. And in terms of actual dollars adjusted for inflation, you can see that the budget's been going down for the last 10 years. In terms of the number of competing awards, and the good news is for breakout of first-time R01s, you could see that it's been pretty stable over the NIH for the last 20 years. Whereas for people that are competing and already established investigators for R01 type grants, it went from a high of 7,430 grants in 2003, and now we're down to 5,000. So there's been a 33% reduction in the number of grants given to people that already had R01s. So also, though, it did go up during the time of the era recovery funds. So the Federation of American Societies for Experimental Biology, or FASEB, quoted that said, for biomedical research, 2013 was a terrible year to have a great idea. And it is kind of a shame when, at a time that there's a lot of talent, that you still may have trouble getting funding just because there's a lot of people that have very good ideas and a strong track record. Here's some pay lines, past and present, that is also taken from the NIH website. And I kind of bolded the columns for NICHD and NIDDK. And you could see that the pay lines for NICHD is around still 9 or 10%. For NIDDK, it's a bit higher in the 13th percentile. Although I think, and I may be wrong about this, but I think for established investigators, it's the 9th percentile, and that for first-time investigators, for R01s, it's around the 13th percentile. Maybe Dr. Pitzkolnik can correct me if I'm incorrect. And this is something that Judy has also talked about, and that's the type of NIH grants that are available. And since mine is mainly about maintaining NIH funding, I guess it's really going from the K awards to the R awards or the U awards. And then there's also other grant types that have to do with program project grants that are called P awards, for which you usually have to be a fairly established person with an R01 in order to get to be part of a program project grant. And particularly in the R awards, besides the major funding mechanism, which is the R01, there's the small grant program, which is only $50,000 for R03s, and then exploratory and developmental grants, which are called R21s, which are a bit more robust at $275,000 for a 2-year funding interval. And this is interesting because I took this off of an NIAID site about should you apply for an R03 or R21, which it always seems like, well, that would make a good idea if you could get some any amount of money quickly. And Dr. Sain said that he had an R03 towards the end of his K award, which makes sense maybe in that context. But overall, the NIAID was discouraging people to apply for an R03 because of the small amount of money it is. And that the amount of money limits the amount of pilot data that you could get if that's your sole mechanism for support at the time. On the other hand, for R21s, this is actually a very nice idea for people that have K awards and are coming on to the last years of that. and that also for people that may have an R01 and that need to make some more preliminary data about another project that's coming along. Here are some of the pros of it. It's supposed to be exploratory and for high-risk research, and its sole purpose was to facilitate scientific ideas and model systems and tools, and to gather preliminary data for a future R01. But the cons are, and I think the biggest con is that although it says it doesn't require preliminary research, when you look at the grants that have been funded, basically like 95% of them require or had a fair amount of preliminary data, and that 2 years still isn't that much time to complete a project, and that it requires up to 20 months to receive an R01 application, as was just discussed in the timeline, and that if you have an R21, then that really only gives you about 4 months until you have to be starting on to actually submit another R01 in order to get funded by the time your R21 is done. Then last is that for your first R01, you have 10 years to be considered an early stage investigator, and this R21 counts during that time, so that you would perhaps lose your eligibility by having this 2 years of funding to get the special consideration that early stage investigators get. Here's just the links to what Dr. Pizziconi talked about in terms of the funding opportunities and the weekly NIH funding opportunities that come out, and pretty much everybody should be signed up for that. You should know what's going on so that when something comes up in your field and there's an opportunity to submit, you should be ready and not depend on the fact that somebody else saw it and maybe told you about it. And particularly, though, division chiefs should review and distribute this information weekly to their faculty. And in my role as a vice chair of research, I look every week and distribute it to the entire department of pediatrics to try to get people to start thinking about ideas that could get funded for which there's money set aside at the NIH. Besides reviewing those RFAs, one thing that's always been helpful to me and as well to a number of my colleagues that I know in pediatrics is to keep in touch with adult GI and liver colleagues. And a lot of departments in GI, you may or may not go to adult GI grand rounds or present your things at adult GI grand rounds, go to their conferences, and make them very aware of what you do, and make allies in a field that may be similar to yours with adult GI. And those people oftentimes get in positions where they could really help you advance your own research and maybe bring you into workshops at the NIH and let you know about other opportunities that you weren't otherwise aware. So when you do get funded, one of the things to do is to succeed at the grant that you have so that you could get another one. And this has to do with, first of all, that you can incur costs 90 days before the time the grant starts, so you really don't have to worry if you know that you're funded and that you have a 90-day notice, that you can go ahead and hire staff and start getting things set up for the experiments or clinical trials that you plan, and that even once you submit the grant, even if you don't know if you're going to get funded, if you have funding opportunities and you have the equipment, supplies, personnel, and capability, then obviously you should start working on achieving the specific aims of your grant so that you enhance the likelihood of your success when it comes time to renew. I think that for most people that are maintaining their NIH funding, meaning they already have an R01 and they're looking for another one, they oftentimes don't have the time to work at the bench themselves, and they depend on having talented postdocs, graduate students, or medical students, and then lastly, technicians or research associates. Those people are key to your success, because if they do experiments that don't work, then obviously you may think that things aren't on track for what your hypothesis was. But getting people that are motivated and that understand your work and know the techniques they're going to make it or break it for you, because it's unlikely that you're going to be doing this all yourself while you have other duties in an academic center. The other thing is that in order to get the grant going, you have to get the IRB approved. I actually like this cartoon that said, "Late at night and without permission, Reuben would often enter the nursery and conduct experiments in static electricity." So you need to have your IRB in place for clinical trials, and if you're doing animal work, you obviously have to have your IACUC approved. And last, if you're in clinical trials, you need to have obviously study subjects. One of the most amazing things about clinical trials is that once they start, all the study subjects go away. That everyone always says, "Oh, I can contribute 10 patients to that study or 20 patients to that study," and it seems that once the study starts, then enrollment is slow, and it's usually a period of ramping up that could be 6 or 8 months before things really get going, and that's precious time lost. And so I think a good idea is, if you know you're interested in an area, is keep a registry of potential study subjects that you could contact in the future. And actually at Columbia, we have in our division and department a research protocol that just says we want to be able to contact you for future research studies. We want to be able to look at your clinical data. We want to be able to collect biospecimens and store them for use in the future. And most people are quite willing to sign those consents so that when a study comes up in the future or something that you plan on doing, once you submit a grant, you're ready to get a quicker start. Next thing is, this applies to people not in basic science labs, but on clinical trials. It's to retain your study subjects. That's really, I'm looking very squat in this picture. I guess it's the, but with me is Jeff Schwimmer, and who's at UCSD, and that's 5 years ago when I was also at the University of California, San Diego. And my study coordinator, who was very experienced at the time, says, we have hundreds of subjects with NASH, and we've got to keep them engaged, and we have to have a way to make sure that we know where they are, what their phone numbers are, what their addresses are, so that we don't lose them in the process of following them in a longitudinal way. And also, lots of times their family members also have NASH also, and we may want to enroll them for certain studies. So in part, it was her idea. She came up with the idea of asking, we put aside, I think, 1,000 tickets we bought to the San Diego Padres game. And it was for the outfield park, actually, so it wasn't that expensive. And we actually called the NIH, and our project officer gave us permission to buy the tickets for the ball game for 1,000 people. We rent out the auditorium at the stadium where the families and the patients could go to hear a lecture about MRI imaging of fatty liver and advances in that, where we also then consented patients at the ballpark because it was their family members. And then we made sure we had the right information for everybody and alternate numbers. And then they all had a very nice day at the ballpark. And I think it really helped then because we actually published a paper on the MRI for all the family members of the kids with fatty liver disease. We published that in gastroenterology just based on that one day of signing people up, which was pretty fantastic. Another time we rented out the aquarium in San Diego and had an event there. And during that time was when we actually had shuttle buses to the GCRC and had the family members, during times that the rest of their family was milling around the aquarium at the Scripps Institute of Oceanography, they go over to the to the GCRC and went into the MRI thing and got their hepatic fat fractions done with some clinical data and anthropometric data. Another study that made a publication just based on a day at the aquarium. So these type of things, you could think outside the box in terms of way of showing your patients your appreciation and engaging them. And then the other thing is, I think that's very important about study subjects is you have to make it easy for them. And first of all, Dr. Menson, thank you for being here. He works with me on NASH and, at Columbia University Medical Center. And one of the things is timeliness. I mean, when a patient comes to the CRC, you have to be there for them. I mean, you can't keep them waiting an hour and then expect them to come back the next time and just be there or even show up. So show that you respect their time. Be there for them, make it efficient in terms of the time of their visit, and get them out again. Obviously, make sure that they get reimbursed not only for their costs, but sometimes for all the other efforts that it takes and costs that they incur in terms of having to hire babysitters or lost time for work. Obviously, it has to be appropriate, so it's not coercive, but try to work within those parameters. And then also, if you're hiring research coordinators, make sure that they speak the language of the majority of your patients, which in a lot of places I've been, that's been Spanish, and that they understand the culture, which is either, that these people are of Mexican heritage or Dominicans, and it helps to have coordinators that understand their concerns. Make sure that you have transportation for them. Or in the event that they don't have transportation, we actually, had a study on the genetics of adolescent liver disease, and we wanted to have DNA from their parents, and a lot of the times, like one parent had come to the CRC and we had their DNA, but we needed the other parent. We actually had like a blood mobile. We rented a van with a phlebotomist, and we went to their house around the entire neighborhood and collected their DNA. So try to make it as efficient as possible for your study subjects. In terms of getting renewed, I think one of the best things to do is to look at grants that were successful and are considered premier when you're starting to write your grant. And on the NIAID website, and it may be on other institutes' websites, there are examples of what they consider the best R01 grants, and also down below the R21 grants. So you could see, how much detail do they want, how clearly written it is, and especially if you don't have a lot of experience writing them in the past, I think that's where you start. You start by seeing how really great grants are written. Then, of course, when you write yours, you have to give it to people that have experience reading grants to get the editing back and have the time that, like Dr. Sain just talked about, to change it. And one other way to really know how to write grants well is to be on study sections. And once you have an R01, you most likely will be asked if you will serve on a study section. And it's something that, one, it's good for your own CV, it's good for your promotion, it's good for meeting colleagues in your field that are considered experts in research. And then last, it teaches you about the process of how things get judged. And when you go to the study section, you see a lot of grants, the ones that are like superb and ones that aren't as well written. And then you hear how people judge them. And through that process, you get to know how to write better grants yourself and also perform a public service. So in terms of the strategy for staying funded, it really is you have to keep publishing. Just because you keep writing grants, in order to keep getting grants, you have to publish, and you have to publish, obviously, in journals that matter. Look at the impact factor of the journal and say, why am I submitting it? Is it just so because I can get it in easier? But that's not a good reason. You want it in a place where it will be read and thought of well and cited in the future. If you're writing a new grant, make sure that what you're going to write about is clearly different than the thing that you're already funded for, because right away you'll be out if it's too overlapping. Think about working with collaborators. It's usually at the boundaries, the margins of a field where new things take place, And if you meet new people and talk about new ideas, the things you could do together, you're probably going to do better than continuing to do things on your own. And this was advice from NIH websites too, is don't submit a new and a renewal application at the same time, because you're probably going to be less successful, and they're going to compare the two, and maybe you would have gotten both, and you probably won't get more than one. From one's different, because the study section will be the same most likely. And the other thing is that always be thinking about your next step. I actually like the stepwise approach that Sohail put up there about how he went up and got an R01 and then got another one, and those two R01s were overlapping, and so you want to have more than one application in the works. Also, you may want to, if you don't have the data, consider a smaller activity code like an R21. I think the multi-project grants are actually phenomenal mechanisms for getting funded for earlier stage investigators or teaming up with someone more senior in your division to work on a collaborative grant that's a U mechanism. There's also a lot of small businesses that they make. The NIH is under congressional mandate to fund small business grants, and those are R01 mechanisms oftentimes, or R21s, and they set aside money for that. And I think the pay line, although I couldn't find it published anywhere, I think it's better than what it is for academic centers applying. And oftentimes the small business doesn't want to be the people there don't want to be the PIs, because one, they're not familiar necessarily with the process, and they also don't want to be held accountable for the certification of their effort that's required by the NIH, and they're happy to work with people that are interested in what their company's about. Last, if you don't get funded, there is something called an R56 bridging grant for people that have R01s. I don't know if that's a mechanism available in NIDK, but this is a grant for $100,000 that will take you through for 1 year during the time that you may have to be resubmitting for another R01. And if nothing else, it shows that you're making earnest efforts to a department chair who may have to decide whether he's going to use internal funds to help you get through a time when you may not have funding otherwise. Here's that no doesn't always mean no, because first of all, sometimes one institute may not be interested in funding your grant, but another institute might, and that there's priorities that the NIH has, and they have a strategic plan. You should read that strategic plan to see what they say they're interested in doing in the future, because that can help enhance your application for an R01 or an R21, saying, I'm doing what the NIH says they want to have done. And you could even italicize their exact comments to show the importance of your work. And sorry, I forgot my train of thought about that one. But the, oh yeah, and so then besides the fact that you get a percentile score, then you go on to Consul, and Consul has their priorities, and they sometimes take grants that didn't make the pay line and move them up, and so that your score is not the only criteria used to make a funding decision. And then when you also don't get funded, you also need to talk to your project officer, and sometimes there was a fatal flaw or something that could easily be fixed that'll make it more likely to get funded the next time. And if you don't get funded at the beginning of a fiscal year, that's because they don't know what their budget is usually at the NIH, and so they are conservative in terms of what they award, and they can postpone consideration of the funding decision until towards the end of the year, when they better know how much money they have and how much money they've already spent, and so sometimes things could have a very long delay. I also want to say that I wanted to tell you a personal story about where no doesn't always mean no, and that's in 2002 when I wrote a grant for NASH. There was an RFA, and there was about 25 grants came in to be a NASH center in the network, and I was the only pediatrician that applied, and they said they wanted to do pediatric studies in NASH. I applied, and I think that out of the 25, maybe my grant was 8th, but they only funded 6. And so I didn't even think about it. I just said, that's really too bad that I didn't get funded. But I did call the project officer, Pat Roebuck, for those of you who know her, and she now retired. And I said, Pat, how are you going to have like pediatric studies when there's no pediatric investigators out of the 6 you chose? And she said, well, we did want to have a bigger budget, and we did want to have pediatricians, but NICHD wasn't interested in contributing. But if you can get the NICHD to give money to the NIDDK, we'll fund your grant. So I thought, well, right, I'm going to call the NICHD and say, hey, give money to the NIDDK, a couple $1 million, and fund us. So I didn't even do anything more about it. But I was a vice chair at UCSD at the time, and one day for a vice chair's meeting, my chairman said, what happened to that grant you put in? I said, it was 8th, I didn't get funded, and the project officer said I should like call NICHD or something. He goes, well, did you? I said, no. And he said, well, I'll call him right now. So he called Dwayne Alexander, who's the head of NICHD, and he said, would you consider funding this? And he goes, yeah. He says, have the statement from the project officer at NIDDK, write it in an email, send us the grant, send us the summary statements, send us your response to the summary statements, say what you want done. And it went to Consul, and lo and behold, actually, they said, okay, we'll fund like $2 million, and it will give it to the NIDDK. And then NIDDK decided to play hardball with NICHD and said, no, we want like $12 million. And anyway, they went back and forth, and it ultimately turned out to be a number in between that, but that's how it happened. And I never would have thought of pursuing it, but listen to what the project officer says and think about a way to get it accomplished. I think that this gets really boring right here when it talks about managing your grants, so I'll go really quickly, especially because I'm running out of time. But fully read your notice of award. It has start and end dates that may not be familiar to you. Look at the terms and conditions and the fund amounts for each year because they change year to year. Make sure you get your annual progress report in a way that's acceptable. And you know that you can't get funded if you don't post public data and deposit biospecimens as required by NIH rules. You need a final invention statement for any grant. And you have to file all the administrative paperwork that has to do with reporting requirements on conflicts of interest, data breach, and conduct and misconduct in research. You have to get a hold of your project officer to discuss any time you're going to change key personnel or practice sites. You have to get permission from them or else it doesn't happen. And you should do it in advance of the time that you see this occurring. And if you change your specific aims or the scope of your research, you need to tell your project officer that too, because it doesn't look good to say you didn't accomplish what you set out to do. And then also with your project officer, not your contracts and grants officer in your department, you have to know that person well. You have to have a good relationship with that person to make sure that everything gets submitted on time and that you know what your funds flow look like and that you're not in jeopardy of violating any rules that the NIH has. I think this was already discussed by Dr. Pitzkollner in terms of the timelines for funding, in terms of renewal. And particularly, you should see that it takes up to 19 months to get funded from the time you may submit a grant. So that means that if you have a 5-year grant at year 3, you should be thinking of having one submitted again. And that means that you also need like the 6 months to prepare it properly, potentially. And so that means like by the middle of your 2nd year of a 5-year grant, you should be thinking about what you're going to do for the renewal. And to stay funded, if you're thinking about having any more funding, you have to, once you apply for a grant, then apply for another one and apply for another one. But these obviously have to be on distinct topics. I think I just talked about some things you had to do to get ahead of the grant. And realize also that at the end of your grant, if there's unobligated balances, which a lot of people do have that, you're allowed to carry it over. And if you, but that doesn't apply to UT and P awards, in which case you have to get the project officer to approve carryovers from that. But then also when a grant period ends for the unobligated balances, you can apply for a no-cost extension, and that could be up for up to 12 months as long as the scope of the project remains the same. And you have to request it prior to the time that the grant ends. So this is my last slide. It's weathering the storm. You can see once again the rainbow at the end of what looked like it was a violent storm. And sometimes you do run out of money after you've been funded for some time. This could be very devastating for people whose careers were built over many years to do clinical science or basic science. And you have to think about the non-NIH funding mechanisms that could either be from other agencies in the government that Harlan discussed, or from industry, and that there are also institutional bridging grants. Sometimes you can get a subaward from other investigators, especially in clinical contexts, to be able to participate in clinical trials. And then, of course, even if you do lose all of that, there's tincture of time, and the funding environment could get better. Thank you very much.